Alright, I have another physics video to do.
We will never sleep, cause sleep is for weak. We will never rest, cause we're all f***ing so throw your diamonds in the sky, this thing go forever.
Speaking of decibels, other than Diamonds Aren't Forever by Bring Me the Horizon, we're going to be talking about an explosion. And I assume that you read the description for the givens and the problems. So, yeah. So first, so we are given the distance from the person's ears to the rocket explosion. Um, and assume that most explosions are spherical. So the distance you're given is actually a radius. And well, we're given the initial distance, which is 100 meters. And then we are given the amount of sound energy, which is 100 decibels. And then we are given the intensity threshold, which is 10 to the negative 12. So yeah. So first, we have to find the intensity of the sound, so we can use it to multiply by the surface area of the spherical explosion, to get the pressure made by the sound waves. So yeah. So as you can see, this is the equation for sound. So for sound energy, which is E equals 10 times the log base 10 of the intensity and divided by the threshold. So first of all we have to isolate the I. So right now we can divide both sides by 10. So if you see log and there's nothing in the bottom in the subscript, that's log base 10. So this b over 10 will become an exponent, and the log base 10 uh will become 10, and it's the base of this exponent. So now you're left with this. So we have to multiply both sides by the threshold. Here's your equation for the intensity of the sound. So since you got the intensity of the sound, we can plug in the numbers. So 10 to the negative 12 is the threshold. And then b equals 100. And 100 divided by 10 is just 10. So by the way, I actually lied. We are actually finding the sound power, not pressure. So yeah, as you can see, we have an equation for power, which is the intensity times surface area. So as you can see, most explosions are spherical, and yeah, anything with a sphere has a radius. So you have to replace A with something with a radius. So 4 pi r squared is the surface area of a sphere. Um, and uh, and yeah, explosions are spheres. If I have to keep reiterating it. So yeah. The area that we are going to plug in is the distance from the explosion to whoever heard the explosion. So plug in 100 for r, and then we can just plug in 10 to the negative second for I, which is the intensity. So you multiply it, and then I got 12,1256.6 watts. But then if you want to go for significant digits, it's 1.26 times 10 to the third watts. And that's my answer for step 2. And now that we have the pressure, now we can use the pressure to get the intensity, but for a different radius. So to finally end this, step 3 requires the power we just calculated to get the intensity. So if you remember that power is intensity times area, we can just divide both sides by the area just to isolate the intensity. So we calculated the power, so we can just plug that in 1.26 times 10 to the third watts. And then the area, since the explosion is a sphere, you plug in 4 pi r squared for the radius, and the radius is 1000 instead of the 100 you got earlier. And now if you calculate it, you get something similar to 10 to the negative fourth watts, and that should be the intensity. So yeah, calculate the sound energy at 1000 meters, and this is the final step. So if you remember, p equals 10 times log to the intensity divided by threshold. We just calculated the intensity, and the threshold is a constant. So so we can plug in 10 to the negative 4 watts to I, and then the intensity is 10 to the negative 12 watts. And then if you do the division correctly, it would be 10 to the 8th power. So now that you have a logarithmic base 10, and the 10 is the base inside the logarithmic, 10 just basically cancels out, and the exponent becomes a base. So log of 10 to the 8th power is just 8. 8 times 10 is 80, and then the sound energy at 1000 meters is 80 decibels. Now I can go to sleep, and the sun's up.